Okay. So taking a look here at some examples on 6.3 in Algebra 3 Trig, just trig functions of angles, their measures, making sure we have everything correct here. So to find the reference angles, 240 degrees, we draw ourselves our little graph here. Remember, this is 180 and this is 270, so 240 would have to be in here. So if 240 is in here, to find the reference angle, I know it's 180 to here. So how can I figure out what it is to there? 240 minus 180, which is 60 degrees. I like to draw. If I draw the reference angles, it does help me out there. Also remember, you always draw the reference angle to the x-axis. Notice how my lines for triangles are always going to the x-axis, not to the y-axis. So negative 202, remember, going this way now, 180 is here. That's 270, so it's in this quadrant over here. So if it's 180 to here and 202 to here, I take the 202 minus 180 and I get 22 degrees. So that's a 22 degree reference angle. So it's something to keep in mind. 3 pi over 4. Like I told you, these are breeze. Okay? Telling you the answer is pi over 4, but here's all the work. It's 3 pi over 4 to there. That's pi. So pi minus 3 pi over 4 is pi over 4. Or like I told you, whatever the base is, it's pi over 4. That's negative pi over 6. How much you want to bet that it's going to be pi over 6? Because whatever the bottom is what it is. So the reference angle is pi over 6. But either way, that goes to here. So you would just have pi over 6. It's just in a negative direction. Okay? Either way, we have them. So find the exact value of 2 pi, sine of 2 pi over 3. Okay, so 2 pi over 3. That's 3 pi over 3 is 1 whole pi, so that means it ends over here. Like I told you, the reference angle is whatever the base is. So the reference angle is pi over 3. Pi over 3 is your 60 degree finger. So your 60 degree finger happens to be your pointer finger. Alright, so put your pointer finger down in your left hand and look at your hand for a minute. Alright, its sine is the square root of the left over 2. Square root of the left is 1, 2, 3, so it's square root of 3 over 2. So you end up getting square root of 3 over 2, but we need to decide, is it positive or negative? In this quadrant, sine is positive. All students, meaning S for students, so sine is positive there. Negative 5 pi over 4 for this one. Well, I'll give you a hint. Pi over 4 is the reference angle. Why? Because pi over 4, it's 4 for the radians. So whatever the base is going to be the radians. So it's pi over 4. The hardest part is finding the quadrant. Well, 5 pi going this direction because it's negative. 5 pi over 4 pi over 4 would be here. So one more would be 5 pi over 4. So it's pi over 4 in quadrant 2. So remember, sine is going to be positive in quadrant 2. So you already know your answer is going to be positive. Pi over 4 is your 45 degree finger. So put your middle finger down on your left hand. So sine is, right, sine of 45 degrees is square root of left over 2, which is root 2 over 2. So cosine of 150 degrees, find the exact value. So when we go to do that, remember 180 is the whole way to here, so 150 will stop in here because that's 90, so it has to stop in here. So to find that angle, it's 180 minus 150, so that's 30 degrees. So my 30 degree finger is my ring finger, so I put that down. So that's square root of the right over 2, which is root 3 over 2. But in that quadrant, remember, cosine is negative. So remember, that should be a negative root 3 over 2, because only sine's positive there, so it should be a negative root 3 over 2. So remember that. Okay, so remember that over there. Over here, 60 degrees, so negative 60 is down here. The reference angle is going to be 60 degrees still, just went 60 degrees down. So your 60 degree finger is your pointer finger. So remember your pointer finger. Put that down. Cosine is everything square root of the right, which is 1 over 2, so it's 1/2. But in this quadrant down here in quadrant 4, cosine is positive. Remember, all students take calculus, C, for cosine. So C meaning 1/2. So C cosine is positive 1/2 in quadrant 4. Alright, and then find the length and the area of the sector. So we need to remember to put things in radians first. So that's 50 degrees. So to switch that into radians, since it's degrees on top, that means it's degrees on the bottom. So I get those degrees to cancel out. So you get 5 pi over 18. That's 16 meters. So the radius would be half of that. So it's 8. So 5 pi over 18 times 8. I get 20 pi over 9, which is about 6.98. Over here, I get 1/2 times the radius squared times theta. I now know the radius is 8. I now know that theta is 5 pi over 18. That's 64 over 2 is 32. 32 times 5 pi divided by 18 is 80 pi over 9, which is about 27.93. And when we come back here, we'll finish up with some more examples. I have some more examples for you, the Marzak's left-hand rule to do.